morning. So we will continue with us with our study of successive substitution. Today we will see one last example. This concerns the movement of a truck uphill. Okay, there are two characteristics involved. You have a load characteristics, okay. You also have the engine characteristics. These two have to match, you will get the operating point. So the problem we are going to consider is for a particular transmission setting. For different transmission settings, we will have different curves and we'll have different operating point. That is why when they say that when you are climbing uphill, when you are in fourth gear, or suppose when you are in fourth gear or sometimes even third gear, you will get some odd sound. That means the engine is telling you that you have to downshift. Then you reduce to the appropriate gear, and then when these two match, so you stay very close to the operating point. So this example will highlight how we do the successive substitution for a two component system. Alright, as is our practice, I will first dictate the problem, then you will start working. In the meantime, I will take attendance. Then the same problem has been written up on PPT, I will show it, and then we will work it out on the board. Then finally, I will show it on Microsoft Excel. Okay. So problem number 7, is that right? 8. Problem number 8. A truck is climbing up a hill. Problem number 8. A truck is climbing up a hill road slowly. A truck is climbing up a hill road slowly. Given below are, a truck is climbing up a hill road slowly. Given below are 1. The torque speed characteristics of the engine. A truck is climbing up a hill road slowly, full stop. Given below are 1. The torque speed characteristics of the engine, and 2. The torque speed characteristics of the load. Given below are 1. The torque speed characteristics of the engine, and 2. The torque speed characteristics of the load. The truck continues to drive uphill. The truck continues to drive uphill. The truck continues to drive uphill at the same transmission setting. The truck continues to drive uphill at the same transmission setting. A. Using successive substitution. Using successive substitution, determine the operating condition of the truck. Using successive substitution, determine the operating condition of the truck for two possible information flow diagrams. Using successive substitution, determine the operating condition of the truck for two possible information flow diagrams. B. Examine the stability. B. Examine the stability of both the operating points. Examine the stability of both the operating points. So for the benefit of people who came late, problem number 7, it's on successive substitution. You can write down in telegraphic language. A truck is climbing up a hill road. Torque speed characteristics of engine and the load are given. A. Determine the operating point using successive substitution. B. Examine the stability. So you have to do it for two information flow diagrams. Alright, I will give you the equations. So, this is problem number 7, we call it as the truck problem. So, omega is the torque in Newton meter, sorry, omega is the speed in RPS and T is the torque in Newton meter. So, the torque T is given by 30 omega minus 175 minus 0.3 omega square and T equal to 11 omega. So, this is the engine characteristic and this is basically the load. So, you can expect that so one is going like this, right? What is this? Okay. So, you may ask me, sir, how do you know it is going like this? It is a parabola, right? It is quadratic. It is quadratic in omega. Therefore, it should have two operating points. So, you can use two information flow diagrams. That is, this information flow diagram can be used to determine T from omega, or you can write omega is equal to T by 11 and use it to determine omega from T. Okay. If you use the equations as such, it will give you one information flow diagram. Okay, I mean one of the two equations you have to change, or you can invert and then have the other information flow diagram. So, the two information flow diagrams should lead to different solutions, but both are possible solutions, but later on we will discuss whether you want the truck to operate at point A or point B. Okay. So, basically the torque speed characteristics will be something like this. Okay. It is better to have a torque speed characteristics such that the torque is basically more or less uniform with respect to the speed, right, so that you get a high torque for most of the speeds. For example, if you look at so for example, the Swift petrol has a torque speed characteristic like this. The Swift has a, so it is an excellent torque speed characteristic because at high speed also it gives good torque. Torque gives you the ability to accelerate, so it won't be sluggish. So it will have the zip throughout. Once the torque speed characteristic show a trend like this, once you cross this, then there is a tendency to have less torque, correct. But the goal of any automobile designer is to have as flat a torque speed characteristic as possible, but subject to other conditions and so on. You can just go to Maruti and then go to torque speed engine specifications and you can get the torque speed characteristics of many of the automobiles. You can critically compare all this. Of course, for the layman this is all too much, they won't even know the difference between torque and power. What is the point in having high power when you are starting at the signal? What do you want when you start at the signal? You want high torque, okay? You want to accelerate, you want to get past the others. So, the torque is very important in those situations. Okay. So, you please start solving. For the benefit of the people who came late, I will now show this on the screen. Start solving. In the meantime, I will take attendance. Initial guess value 40 RPS. Is it all right? What is it in RPM? 40 RPS is how much? 2400 RPM is a good speed for the engine. It is all right, right? It is not a bad guess. You should not start with 2,40,000 RPM for example. You should not start with 24 RPM. So, what is the idling speed of your Hero Honda for example? Hero Honda will also be about 50,000. Cars, when they idle, it will be about 1,000. Now they also have a tachometer, right? All the modern cars also have the tachometer. So they say that whenever, even if you go to 100 kmph or 120 kmph, they are always asking you to look at the speed. You should not try to go at 4,000 because the strain on the engine goes up if you try to increase the RPM. Okay, there is no, you can go fast, that is not a problem. But when the speed also goes up, right, I mean the RPM also goes up, that means you are not at the appropriate gear. For example, if you go at 70 kilometers per hour in third gear, then it will show a wild, it will show a wild RPM, that means it says change to fourth and fifth. Okay, so it is for the benefit of the user, right. So for people who came late, this is the problem. I have given both the equations. So one is a quadratic, one is a, I don't want you to make the whole problem silly like substituting for t here and solving it as a quadratic. That can be used for checking, but basically I told you this is successive substitution. From one equation you input omega, get t, from t you again get omega until it converges, because this is a methodology I am teaching you which will help you to handle multi component systems, alright. Okay, so I think the basic idea of asking you to solve the problem with two information flow diagrams is to ensure that you get both the operating points, right. So we will first draw the information flow diagrams. See, this is for a particular gear setting, okay, with different gear setting you can, some characteristics will change, okay. So that is why I told you that when it is climbing uphill, if it changes the gear, then we are in trouble, then it cannot, maybe it cannot be solved in the classroom, or not that it cannot be solved, maybe in a classroom environment it may be difficult. Okay, information flow diagrams. Okay. What am I doing? So engine is one information flow diagram, okay. The other information flow diagram is okay. So the first step is to draw the information flow diagrams, and then appropriate to the information flow diagram you draw out the tabular column, serial number or iteration number, omega t, then decide on an appropriate stopping criterion and proceed with the iterations, okay. So let us start with which one do you want me to start off with? First one, okay. So serial number, initial guess Yeah, what is the error criterion we want to use? Sum of omega I plus 1 minus omega I whole square plus t I plus 1 minus t I whole square. Okay, so I will say norm, okay, iteration 0, so this is the way to start out with. Iteration 0 I do not calculate anything, I just start with the initial case. So, I do not fill up 2 columns, column pertaining to t and the error. Now, let us go to iteration 1. So, what is a from omega I have to calculate t, is it? So, what is the t you are getting? 545, that is good. T is in Newton meter. Five 45 divided by 11, 49.55. Now, is it possible to calculate the error? Now, we have to wait for some time, right? The error on this is not known. Okay, 49.55. You again substitute here 49.55 into 30 minus 175. You can set your calculator so that you can do it fast. 574. Yeah, what is this?
52.5.
Just go up and down. The equation will be saved. Okay. You just have to variable
No.
that equation.
Now tell me this. With these two, this minus this minus this, how much? 49.55 minus 40 whole square plus 574.9 minus 545 whole square. How much is it?
Around 1000.
800, 900, how much is it?
1000.
1000, exactly 1000.
Something like that.
Don't be lazy, Deepak. So 574.9. Now you do this divided by, it goes to 52 or what is it? 52 point. Now you have to again do this. 570, 8.6. Yeah. Now 9 plus 1 10. How much is it? Varun,
I'll calculate
Do
only
it.
when these two values are matching. Final values are matching.
Deepak, tell me.
Sir, we need to calculate error only when they are close together.
No. Don't try to minimize your work.
9.03.
Then you will do the same thing in the exam and then you will argue with me. Okay, 573.6 and this is 52.1. Now 573 point. Now you please calculate this. Point not 1 is it already? Konta ready?
52.14.
52.14. Yeah. Because you are cutting down to 2 decimals. You are getting the same thing? 573.6. One 1.5. So please report the error here. Okay, so we got the fine. So we use one of the two information flow diagrams, namely information flow diagram A. It was pretty straightforward. you did not have to solve the quadratic equation, okay. So, it is pretty straightforward, you successive substitution got you to the answer of 52.15 multiplied by 60, it is about 3100 rpm, but nobody will go up the truck with 3000 rpm on a hill, okay. This is something which you have to avoid, right. We will go in a lower gear, generally you do not exceed 2005 rpm. Therefore, it is imperative, no, I am not saying that this is a wrong solution, incorrect solution or whatever, this is one of the two solutions, anyway it is a quadratic cuts a straight line, so there should be 2 points, so we should turn around and find out the other operating point, okay. Yesterday Vinay asked me a question, when I tried to plot all these on Excel, I think some people misunderstood that as you employing the successive substitution method on Excel. There is no way of, I do not know of any way of employing the successive substitution on Excel. What I did yesterday was just plotting of the two curves and intersection. So, I graphically depicted how the solution looks like, so that your understanding of the situation is complete, right. I did not put the algorithm in Microsoft Excel and solved, I just took some arbitrary values of the parameters and found out the fan, I used the fan curve and I used the duct, and then we saw when these two were intersecting, okay. But Abhishek told me there is a way of doing it and we can actually put it into recursive relation and actually show it on Microsoft Excel, okay. Now, shall we go to the other information flow diagram? So this is your correct answer, omega is 52.15 revolutions per second rps, and torque is 573.62 Newton meter, okay. Now, we will go to the other information flow diagram. So, in real life or in the exam, if you get the other information flow diagram, then anyway I have asked you to obtain both the operating points, it is incumbent upon you to draw the other information flow diagram and extract the other point also, right. And in some cases the other information flow diagram may completely diverge, in that case, in such a case you have to draw the information flow diagram which you originally thought will not work and then rework the problem and finish off, okay. Generally I will check before giving you a question, I will check that the problem has a real solution. So, one of the two information flow diagrams will usually work. Why am I saying one of the two information flow diagrams? Usually we are looking at two component system, and generally for these things two types of information flow diagram alone are possible. So, information flow diagram B, okay. So, first step is the same. Now, we proceed to so now what do? You substitute 40 here and then T is how much do you get? 440. Good. So, T is 440. No. What did you do in the first one? Okay, you did that. Okay, now you have to go to this. Now you will get 440, right? Okay, good. So 440. Unfortunately, with this 440 you will get two values of omega because it is a quadratic. One of the two will cup, we will see. Hang on. Solve this. Huh?
I've
The
taken only
later
one of
one,
the
the smaller one.
No, you cannot do that, Vikram. First we will allow things to fail. 7.71 point.
28.79.
I still cannot calculate this because I have not completed it. No, so now I work with 71.29 corresponding to 71.29. What is the value of omega I am getting? Okay, so I will say A and B. A 7 point, B 360 point. Rajesh baby, tell me. Venu.
I did with a different starting guess.
Huh?
I did with a different starting guess. My starting guess was 5.
Why?
Because you said the answer will be smaller.
That's cheating. You must have got it in 3 or 4 iterations.
Much faster.
No, because I drew the plot. No, that's okay. But generally, since I want all of you to go through the steps, you better to stick to 40 RPS. Soumya, what's the matter? Things are not working or? Kaustubh, tell me. So 783, what is the other one you are getting? Okay, this one? This leads to what? $75, huh? Imaginary. So please look at me now, please stop working. So you are getting minus b root of minus b squared minus 4ac by 2a. So the moral of the story here is when you minus b plus or minus root of b squared minus 4ac, if you consider that b squared minus 4ac by 2a, if you will get two roots, one of the two roots will automatically diverge. Therefore subsequently you take a chance that you look at which of the two roots diverges, and then that root I will not consider in the future calculation. So anything which goes beyond 50, 60 or 70, you just ignore the other root. So look at the other root which is proceeding towards the lower value of omega. So that will be the true solution, okay, because you already know by plotting, but that is again cheating. So even if you, or you can use the plain vanilla approach, you do not worry about anything, you just keep on working out the two solutions and discard the solution which leads to imaginary roots. Ultimately you will end up with the operating point A, right. So 316 will lead to, and now you can work out the error, okay. 440 I will do it approximately. So it's this about 120 whole square is how much? 14,400 plus 400, around 15,000. Okay, so 15,000. Now using this 20.6, use the B. Now you lose 20.6 into 11, right? 223 is it? 227, good. So from 227, good, 15.9. Now you can find out, right? 316 minus 227, this is about 90. 90 whole square is how much? 8,100. Okay, 8,100 plus 25, about 8,000. but still it's large. Okay, so using this 15.9 you can again work back. How much are you getting? 175.4. Okay, 175.4 with this. So this will be about 50, 2500, so about 2500. You can see it is rapidly decreasing. Okay, 13.2 will give you about 150. Okay, 11, 12 point, okay, 12.3. So how much is this? 140, 150, 25, 625, 600 and it's still way off, but it's converging much more slowly compared to the other one, right? So I have worked it out. So by the 10th iteration or so, okay, 10th iteration I am getting 123.8, 11.22. Okay, so this is more like it, 11.22 into 40, how much is it? Around 500, 11.22 RPS, that is about 500 RPM. Okay, so generally all, have you seen trucks climbing? All the other vehicles will easily overtake them, they absolutely cannot climb. So even the small vehicles can overtake, the Maruti 800 can overtake a very big truck, but as soon as it comes down and then on a level road, since his power is more, after a couple of miles he can overtake. Okay, but if you see actually in those days when many bikes were there, the kinetic Hondas were the first to come out of the signal because of the excellent torque, right? When they you can accelerate, even now the Honda Activa and the Hero Honda is 4-stroke. I mean Hero Honda will struggle, Splendor, this thing, whatever. I am not talking about the big ones which have got 150cc and all those Zany and swanky new bikes. Okay, the old classic CD100. It got only about 7 horsepower or 6.5 horsepower originally, it will struggle, but then after it stabilizes when you come to 4th gear, then you can overtake. Initially it will not, it is only the Honda Activa, Honda Dio and all those guys who will really zip past all the others in signal, right. So this is the story as far as this problem is concerned. I will now work it out on Microsoft Excel, or shall we skip it? Huh? Who wants me to do it? Even if there is one person, I have to do it. Okay, fine, that is good. So now you have to examine the stability of the operating point. Now let us for the sake of in the interest of time, let us do the stability analysis only around point A. So all of you please examine the stability around point A. How did you approach point A? You approach from 40. Venugopal already approached it from 5 and got the answer, but we will check it now. Okay, so please approach it from 0.9, or you start with 9 RPS or 10 RPS and do 2 quick iterations using information flow diagram B, and get yourself convinced that the problem that it will hit the same solution of 11.22. Okay, so examining the stability. Do you have the next class? Yeah, please do this. We start with 10, what do you get? Torque. What is this? No, T. 110. Omega 10.6. Then T 116. Omega. Okay, so we will just suffice it to say that proceeding towards since we got the solution by starting from 40 and you hit the right solution 11.22, when you start from 10 also it is proceeding towards A, therefore it is a stable operating point. So you can go back to your hostel rooms and also investigate the stability at operating point B. How did we approach B? We started from the left side of B. Now you start from the right side of B and let me know in the next class whether it is coming back to the point B. Any doubts? Yes, Venugopala.
You get dou P by dou omega is equal to 11.
Okay.
But it's still very stable. We get an answer.
No, but I told you that the other derivative will be very small. Okay. So even if one of the two derivatives, yesterday also there was a lot of confusion. All these will be resolved once we look at the Newton-Raphson method, where we use the information on the first derivative to approach the problem. Okay. Anyway, I will just take a minute and graphically tell you what the Newton-Raphson method is, and then we will. I will just take 2 minutes, and then in the next class we will work out the algorithm. Now let us consider y is a function of x. It is a one variable problem. So this is f of x, right? I want the roots of f of x, that is I want to find out where f of x becomes 0, that is what we are trying to do using successive substitution also in making this f of x equal to 0, and then that is how we get the operating point. Now this is the root. Because the equations are nonlinear or transcendental, there is no direct way of finding the roots. Therefore what we do is we start with an initial guess xi, and then we draw a tangent at this point. Okay, and wherever it cuts the x axis we call that as xi plus 1. So this will be xi, so this will be f of xi. Okay, so what is this? F of xi minus, correct? What is this? X of I minus x of I plus 1, correct? Therefore dy by dx at xi is equal to so if you do this, this is the Newton-Raphson method. Okay, so I will derive the same equation using Taylor series expansion. So we will do the derivation, I will repeat the derivation graphical method, we will also do it using Taylor series, we will solve a couple of problems, some simple transcendental equations involving trigonometric function, problem number 1, then problem number 2 we will do the electrically heated wire, and then we will revisit either the choice is yours, we will either visit the fan and duct problem or the truck problem, one of the two problems we will solve as a Newton-Raphson method in multiple unknowns. Okay.